D
here,
dot
right?
read line is not equal to null.
It looks like it did at the top, though. There's some information at the top of that.
Oh, yeah, it reads the whole thing through.
Okay.
By
It
the
just
time
doesn't
that
stop.
happens, we can't even go back far enough.
Gotcha.
So what happened here is we read this thing and then we print out the string, and then what happens is eventually this read line returns null if there's nothing left. It says lines carry return following or by reaching end of file.
Have we stored this in a collection at any point?
Not yet.
Okay.
We're
'Cause
getting
I was
there.
gonna say, then we could just use has next.
Yeah, but
So we
we're
can,
just reading it now, so we gotta figure out how to read it in.
so in while condition,
Yeah.
you can just put RD dot read line is not equal to null. It will stop as soon as there is.
Mhm. We could also do this, right? If S is equal to null,
Yeah, you can. do
done
that.
equals true, else, like that
The output, was the first one, no?
was the first one, no?
In the output, you go all the way up.
No, it won't, it has printed so many of those you don't know. But if it was, this would stop instantly,
Stop.
but it doesn't, so. Now, what's interesting is you're not gonna see the whole file here, because, part of the reason for that is that the console isn't big enough to hold that all. So what we can do is we can actually go into Windows Preferences, and I think it's in General, Editors, Text Editors. We set the label console.
And that's just a matter of giving your program, like the IDE, more memory.
Yeah,
Okay.
well, you can tell it how many lines should be in there.
Would it, in an event where it's not realistic to do that, where you maybe have hundreds of millions of lines or something, would it be a good solution to output a different file from that program, from your program, and then go into terminal and find the difference and see if?
Oh, yeah.
Okay.
Windows Preferences, Run Debug Console. Windows Preferences, Run Debug Console. Number of lines. Console buffer size is 80,000. Now it's 800,000, and we know this one is 525,000. So this should fit the whole shoot match now. Yep. But look, I get weird characters in there, which is really kind of strange when you take a look at the file itself. And in this case, we're going file March. And we look at this file, I don't see anything there.
Is it metadata? It's
No,
just
this is a
your-
text file.
Oh,
Something to think about. There's probably something, some characters in there, even though this is a text file.
so like a hidden icon or something?
Yeah. Or some
That can't represent.
control characters
Ah.
or something like that. All right, so now it reads all that. All right, that's step one. Now, let's print it out as words, right? And you know, one of the things that's really interesting is that how many lines do you think this thing actually returned? So, I mean, if we go into here, just for the heck of it, let's say int counter equals 0. Each time we read one of these, we'll say counter plus plus. At the end of this guy, when we're done with the while loop here, yes. When we're done with that, what we'll do is we'll now say, here's how many lines were there in there.
You have an open brace on your while.
Oh, yeah.
Now, when you print the line count, it's also going to print the count of empty lines, because you're just reading until the carriage return, right?
No, I'm reading until it comes back with null, which would be the first time with no line. An empty line is still a line.
That's what I'm saying, if it's just an empty, if it's space or white space.
Yeah, or carriage return, line feed, that kind of thing.
Okay.
Equals plus counter. So let's see how many that came up with. There should be one more of those there. And let's see what happens.
104,
Lines equal 9,568. When we ran word count on it, it said there were 9,568. All right, so there's step one. We know how to read the number of lines that are in the file. Now we need the number of words. So in order to get the words, what we want to do with this is we want to actually add these strings onto a buffer that we're going to keep inside here. So we need a copy of that guy. So we'll say the string buffer, and let's do this because it'll make it easier. And then buffer equals that, and then what we'll say here, nope, actually we don't want to touch that one. Then what we'll actually put that there either. We do need it here. What we'll say is buffer plus equals s. So that will just keep, each time we read it, we'll keep adding it to a buffer, adding it to a buffer. When we get to the end, it's going to be one giant string in that buffer. And so we do have that counter, which tells us the number of lines. I think that we need to promote that guy. Where this guy here is inside there, we actually would rather he be a class level variable. And we need to go up and make all these guys what they should be. This is private. This is private. This is private.
The string, when it comes back, doesn't have a new line, because you're using print line on the string, and we're seeing that the lines don't have two carriage returns. So when you add it to the buffer, you're gonna be missing a carriage return as a delimiter, so we'll get the word on the end of the line concatenated with the word on the new line with no space, white space. Won't be able to parse it.
Let's see.
You won't be able to fit it, because, oh no, 800 will be able to fit it.
Looks okay to me.
Where are we printing out the buffer?
Yeah, well, we're not printing it out. We're printing it out as we do it. So let's stop that, and down here, we'll print out the buffer. Well, actually, let's do it before this one. It's only one line long.
Well, it's okay for it to be one line long. I'm
Well,
saying
but
that
the
you're
problem
gonna
is,
get
this is
columns
the
and
problem
this.
right here.
Yeah, that's the only problem.
Can you insert there's a word for it, but a special delimiter that you know?
Well,
So,
why wouldn't we just?
like
do-
right there, every single time it goes to a new line, you have some like line bar or something that says, okay, look for
Why
that.
not just do this?
Yep, that works.
Okay, yeah,
Just add space to it afterwards.
yeah.
So now if we do that, where that says that Lucas Collins this, we run this now, you'll see a space there. At least you should.
Yeah, 2 spaces.
That's weird.
Yeah. Takes a while to read through the book.
Or it's the fact that we're adding the string to, creating a new string every single time because it's not a string builder.
string builder would still be a pain in the neck too. That's weird. I mean, if we had a space there.
Well, if you put a different character, like an underscore, would it also double that up, or would you put a space in?
No, I'm pretty sure I know what's going on there, and that's a good experiment. I mean, let's say that we put an asterisk there just for the purposes to see what this thing does. And this thing runs.
2, okay, so it's definitely, okay.
Oh, could it be that there's 2 blank lines there?
Yeah,
That's why there's 2 spaces.
Yeah, so it replaces the second
Yeah.
new line with just a blank space, which is okay. So that's fine. I mean, we could also put a new line in there too. But let's leave it as this because this actually helps with splitting it up now. So now we have the number of, this stuff is all in there. So now we have the number of lines. We should be able to split that guy, right? So if we do that, and it's gonna look weird, right? String split, but this is an array of strings. It's going to be equal to buffer dot split, and then we have to pass in a regular expression. In our case, we just want to split it on spaces. Yep.
There was one thing that we mentioned earlier in the course where you put the double square brackets before instead of after,
Yep.
because it's in reference to like Java versus another language.
Yep.
Is that something that we have to keep in our mind moving forward, or is that like a?
And logistically, putting it there is really the same thing as putting it here. It's just Java prefers it over there, and C++ prefers it in the opposite spot.
Oh, but it's not gonna be like, oh, if you do this, like,
Nope.
get out.
Nope, not at all.
Since it's a regex, should we say W plus instead of just space? W being white space?
Well, the split is going to be, splits the string around matches of the given regular expression.
So
So
if we had 2 spaces in a row,
it would work, it would just, well,
it would give us a blank.
a blank word.
Right.
Oh, we're getting there. We're
Why
getting
not
there.
use W?
We're getting there.
All right.
So, this is like building on top of things here, and we want to make sure we bring everybody
I will be
along with
patient.
us.
I'm
Okay?
sorry.
We want to make sure we bring everybody along with us. So if we run this, now we get this split, and what we can print out is, what's the length of the split, right? So, length of split is, and she used double quotes probably. And this should tell us how many words it thinks there are so far. $99,288. It says 86,464. So we've got a lot of extra ones in there. So, I think that was, what did it say? It says, new line, word, and byte counts. Yeah, so we're looking at words now. We're saying there's 99,000 words. It's saying there's 86,000 words. So, that means that our splitter isn't quite right. Now, one of the things that we want to do is we want to try to fix that. So, what Peter was saying is that, well, we could do, one or more spaces makes a word. We could also do a collection of punctuation to differentiate that. So what we might want to do is something that looks something like this, right? So there's a space, there's a comma, there's a period, an exclamation point. Right? So that's our regular expression, and we want at least one of these, right? We can't have 0 or more of them. One of them would be the right thing to do. Does that work?
It's still not gonna be super accurate because there are some things that don't count as words that would be broken up by that, such as the URL. It's a very small thing that's gonna be off, but it will be off.
Yeah, but slashes are okay.
No, but like .com, so com would be considered a word.
Yeah,
How about apostrophe?
apostrophe.
No,
No,
'cause
you
if
don't
you
want
have
apostrophe
possessive-
part of the
Just
word.
There's a way
Let
where
it be
you can
one.
set up, like everything but characters.
Right. So, how do we say everything but characters? Well,
It's,
Correct.
instead of,
Dot.
it's,
Regular expression?
not.
I mean,
it's a regular expression.
Is it
but
not
we
A
find-
dash Z, capital A dash Z, it's like not that? Is
Well,
there a
we
way?
could do that, but we also have ways to do
A through Z.
word characters or not word characters, right?
Yeah.
I
One
don't
of them's
know.
uppercase W and the other one's lowercase w, right?
I didn't know that. I would've looked it up.
We talked about it.
Oh, fair enough.
Isn't there like a colon notation too? You do colon, punct, colon?
Yeah, yeah, as long as they're in order. I mean, you'd have to know what's the first one in the sequence to which one's that way.
Maybe I'm thinking of Python, but it was this special keyword that would, you did colon, punct, colon, it would,
Yeah, that's Python.
Yeah.
yeah, sorry.
Yeah, I think that's Python.
Wrong class.
So what if we have is lowercase w. And if we look up regular expressions,
You can also use is letter.
yeah, but it's not gonna break up, then we're gonna have to process all that stuff ourselves. We'll have to take a look at each individual letter and build each word and all that kind of stuff.
All roads lead to Amazon.
Yeah. Here we go. A, B, or C, not any character except A, B, or C. Where's the W's? No W's. Here we go. Any word character is a lowercase w, any non-word character. So /W. So what we could do is then take a look at if we used a /W, and it actually has to be a capital W. And we need the square bracket at the beginning. Whoa. It's still not happy.
Slash.
Yeah.
Yeah.
Remember,
Would
I
it
asked
escape
you
it?
if there's a way you didn't have to escape them.
No,
You said
without,
no.
without the.
What a pain.
Without the brackets? Yeah, we would need the brackets if we were doing more than one character, but this should work.
What's the name?
One or more occurrences of. Ooh,
So maybe
Yeah,
you
I
do need.
thought-
angling meta character plus near index 0.
I thought the
Plus.
plus had to go on the end.
Yep.
Oh, yeah.
Is this stuff I should know? Like off the top of my head?
See, we haven't- we've
If
read
you
this
use it
before.
enough, you'll get to know it. If you don't,
I mean, I use regular expressions, but
so.
You will,
Oh.
one of those computer classes you use, you go to sometime in the future, this will be on the exam, guarantee it.
So yeah, you
This
know
is
what,
my last
you're
computer class.
guaranteed that regular expression processing is gonna be on the exam here too, but it's in the book.
yeah,
So-
I was gonna say, I'm just.
Yeah.
But now the
Just
length
Google.
was split
I
is
usually-
You can't
88,753
No, on a job, it's in school.
That's a lot
versus
closer.
86,494. We're getting closer.
All right.
So can we review the actual file to see where we might be messing up?
Well, there's one, and yeah, the file's right here, so.
Is it considering any sort of contraction or possessive not a word?
Those would be separate words. I mean,
That would add on to it, so
yeah,
if you
like
have like
dog,
leave,
dogs with an apostrophe,
so
S
S would be its
would be a
own.
separate word. So what is this saying? Any digit, any word character, any non-word character, a word boundary.
I don't know what that is.
I don't know, let's see what happens.
Ooh.
Well, that changed it pretty radically. I kinda like that better. Let's go with that for the time being. Alright, now we have all these words in there in a word array. Hey, can't we use like arrays.as list and put this into a collection? But one of the things we wanna do now is, as we go through these, we would really like to be able to say, here's a word and here's the count that's associated with it. Because one of the things we want to do is we also want to know how many unique words there are, or how many words are, which words appear the most times, and all that kind of stuff. So we can build a map out of this. And what's interesting is in the slides that we had earlier, it did this kind of thing right here. If the map contains the word, then what will happen here is we're building a map and putting it inside there. And if you see, this has a map of string and integer. So we want to build a map of string and integer to pop this guy into.
I have a question regarding this. In real, as a software engineer somewhere, would you be using these things, or would you be going the traditional way and looking?
No, it depends on, I mean, look, there's a couple different ways to look at this. If I told you you have infinite time to do this, you can do it any way you want. If I tell you I need this by this afternoon, what are you gonna do?
Correct.
This.
You're gonna start
So it
right
depends on-
away.
It depends, I mean, there's always constraints on what you're doing. And, you know, it's like, it depends on what those constraints are. So in our case, we can now build a map based on a string and an integer. So, we want to build this map. If we look back at the slides, what he's doing there, he actually builds the map. Where is it? Man string integer right there. So we want to do exactly that. And bring that guy up. What do we get? Map string integer. My map equals new map. Let it infer the rest of it, and it's done. Now it's going to tell me I need to import map. Import map. Good. And what's this going to say? Cannot instantiate the type map.
We need to choose a type of map.
With this, you're using string
Oh,
and
it's a hash,
integer.
we're going to build a hash map.
it's
Yeah, because
a
map is
generic-
the base class,
The
and
base
it's
class.
abstract.
Yeah.
So,
With this, you have the diamond notation to the right of hash map. What is it inferring? Is it inferring a string?
it's inferring what
and-
comes from this back here.
Yeah, but it's a string and an integer, so which one? Is it doing both?
Yeah.
Oh, because of key value pair.
It's a
Okay,
key value pair.
I'm sorry.
So now we have a hash map to put this in. Now what we're going to do is we can actually go through each word that we picked up in our split and insert it into here. And then if it already exists, we will bump up the counter and store it back in there. If not, we'll add it. So the first thing we want to do is put a for loop in here that just basically says string w : split. And what this is going to do is it's going to pull all of the words in order out of that array split. So now we have them. What we're going to do now is we're going to say, hey, we want to, if it already exists in the map, let's get it, bump its counter, and do what we need to do with it. If it doesn't exist, that's the simpler case, right? So it's my map dot, let's see, How do we get this guy? It's gonna be right here. My map, create map, display map, create map, map.put. So the default case is gonna be this. Dot put, and we'll want, this one here is basically what we're gonna do. So the key is W, and the value is 1. That's the default case. If it's the first time we're seeing this word, we'll do that. Otherwise, we're going to have to see, is it in there first? If it is in there, then what we'll do is we'll get the counter from it, bump it by 1, restore it back in the list.
So it'd be my map contains key and then W in parentheses.
Custom one.
Contains key. So what we want to know, does it contain this, which is W?
Will this be an if else?
Yep.
Okay.
If my map contains key W, then we got to do something. Else, we do this guy. So what we want to do, if it does contain that key, is this little section of code right there. If it contains the key, we get a count, which gets the word, gets the current count for that word, and then we just put that stuff in there. Cut this out of here, that's a picture. I hate that, that's a picture.
So it's actually removing the word, and or it's saying is the word there and then supplanting it with a new counter?
Yeah,
Okay.
that's exactly what it's doing. So in order to get this to work, we gotta go int, int c and t equals my map dot get w. Then what we'll do is we'll do a my map dot, was it put? Did we put back with put? Yep. And then what happens is we just put that guy back in. We'll put in W, comma, CNT plus 1. All right, so now,
Why wouldn't, when you're declaring the value of CNT, why wouldn't you add one up there for that case and then just put in CNT in the put? Is there an advantage to doing it to get it there? So logically,
Doesn't
okay.
either way is fine.
Okay.
This should give us a map that has all of the words and their frequencies. So with that in place, let's modify what we're putting out here. We don't want to print out the buffer. Lines is good. Length of the split is good. Once this is done though, it would be cool if we did something like this. And you know, you mentioned I and J. That's actually a throwback all the way back to Fortran. Because I and J
Yeah.
were default integers. So you didn't have to declare them as anything because they defaulted to being integers. So they were always used inside loops because I and J were automatically declared for you. And that's where that comes from. I is less than, let's go with 25, I plus plus. And then what we'll do is we will print out my map dot get, how do we get one by location? It's a good question. Yeah, I'm gonna pull something out of a map by index.
It's not in order, so you can't iterate it.
Why not? It's like, the iterator just goes over it, doesn't, I mean, we could build an iterator to it, yeah. Because that would be the right thing to do.
But, yeah, I guess there isn't any order anyway,
Yeah.
because we're.
Yeah, you gotta iterate over it. So. Keys that get I. Yeah, there's no defined ordering of keys. Map that key set, map that key get. Now, I think the right thing to do is probably to build an iterator to go over the top of it. So if we wanted to do that,
You can't use index of it.
is there an index of it? No.
Because there's no order in that.
Yeah, you typically look it up by key. So what we could do, I mean, can we build an iterator over the top of that? No, let's see.
In the book, an iterator object can be used to walk through a collection and remove elements from it during an iteration. What else can an iterator do?
But a map is in the collection.
Oh.
You can.
You know, I think we got it. Let's grab this code real quick. We'll modify the heck out of it, but doing this inside here. Alright, iterator equals my map. Got entry set dot iterator, got a import iterator, we do not want from swim, we want from util. Alright, it dot has next. Now, actually what we're gonna do then is we're gonna actually grab this one, because we're gonna put out the first 25. Get rid of that one. Map.
You can put the IT has next beside the war condition.
Yeah. Yep. And I could put it there, I could also do it down here. Alright. Now, so this is doing a map entry dot infer generic type argument. Alright, so map dot entry. Pair equals map dot entry IT dot,
So entry is a class property.
yeah, it's well, it's a value pair, a key value
I
pair.
still don't know how hash works. You know that.
Well, it's just a,
It's a nested class, right?
yeah, it's a nested class which just contains the key and the value.
Okay.
Now, yeah, it should be parameterized. Yeah, so what we should do in reality is that this should, in order to make this look correct, this should be string integer. And then this one should be like that. No, it's not going to do that. Incorrect one, yeah, you actually got to do the same one here because it's a cast. So because it's a cast, it's not going to let you get away
Yeah,
with
PDF of the book.
ignorance.
You have a PDF of the book.
Yeah, I don't care about the objectives. All right, so. Let's do this and this. should print out the first 25. Hall is 17 times inside there. So, let's see. Prep dash IN hall.
Key the case.
Yeah, so we can take out the ignore case and txt.
How to choose all of those words?
I just picked the first 25.
Gotcha.
Oh, yeah. Wow.
Was France a country back in 800 BC?
No idea.
Or it might be
It
related
might
to
be
the
part of the
file.
copyright
Gotcha.
stuff inside of the file. Yeah, this does haul and shell and all that kind of stuff, so what we would need to do in order to get that right is this can be, we can put a space in front of it. And we end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25.
More than 14.
Yeah, which means if we look at the singulars and the halls, oh, because this also does halls. So we want this to be space before and space after.
And you can put minus C when you do the count.
Yeah.
This might be a stupid question, but do we have to learn how to use terminal to be successful in software?
Yes.
Yeah. It's not as scary as you think it is.
I just want the
It's so
pictures.
scary.
I like pop-ups.
All the text.
When things break, when everything's broken, that's what
That's
you
where,
get.
that's
Yeah,
what's
you're
in
down to
the
here.
book.
All right, we're close, so why don't you take 5, come back and we'll finish this up, and then we'll move on to talking about what's gonna be on the midterm. What's that?
What parameters is terminal using for like delimiter for this, for that? Like we're trying to match it up to terminal's count, right? Of words, of lines.
Not terminals count, terminal doesn't care.
Is it, is it?
Grep,
Huh?
grep is looking through the file.
What, I don't know what grep is.
Grep is the command we've been using for the last 10 minutes.
No, I know, I just don't know what it is.
It's a regular expression processor to look through text files.
Oh, okay.
And its origin is Unix based from way back.
Way back in the 60s.
So just before I was born.
Yeah, so.
But it's on your iOS. iOS has it in the command line by default.
You can get command line in the iOS.
Yeah.
I'm learning so many things.
Okay, I didn't.
Right.
I'm glad I'm not the only one who's ignorant around here.
So now, the last thing we want to do here in order to finish this all up, it would be really, really good if we were able to print out the top 10 words that are used the most. In order to do this, we could do a couple different things, right? Inside our map, if we take a look at what functions are available from a hash map. So Java hash map. This guy here, and here's our functions inside here. Compute contains entry for each get or default is empty, key set, merge, split, put all, remove, replace, size, values. Returns a collection view of the values contained in the map. That would be the values. We really don't care about that. We want to figure out, we have this list here. It's got all these words in here. We want the 10 most used words. And there's a couple ways we could do it, and what we already have here, we could go through and find out whatever the top 10 are and save them, or maybe we could sort it.
Which is easy with, this isn't a collection. Shit.
We could create a new collection.
We could create a collection out of the map entries.
But wouldn't that double memory size?
Sure, but that's not what we're here for. We're here to just try to figure out how to find the top 10 words that occur inside this book.
Okay.
So, I mean, we could make a new collection out of that. Ooh,
I have a follow-up question.
okay.
What if there's some tie for the 10th word?
Then we'll hopefully grab them all, right? Sort hash map, Java. See what it says. How to sort a hash map? What a stupid question. Thank you.
It's right first.
You want to sort by comparing values in a hash map. You have to write code to do this. If you want to do it once, you can sort the values of your hash map. We could use it as a, we could do it as a tree. That would do it. Because trees would automatically sort it as you put it in there. Can we change that quickly? So, what if you did this as a, is there a tree now? That's a tree set. Oh, no, there is one.
Hold on a second. We want, first time we do it, we want the key to be the string.
Yeah.
So it's correct for the map. You
Yeah.
could use a tree, but you're not gonna really get anything. The second time we use it, we wanna sort by a whole different key, which is the integer.
Yeah.
So it's like we need a whole different container with a different sorting methodology.
Well,
Because the map's already being keyed by the string.
yep.
And we want a new container that's keyed by integer.
Split tree.
That's funny, in the tree, they all come back in alphabetical order. Because that's what a tree does. So, it returns us to first things alphabetically, which is kind of close. But, like I said, we want to flip the key in the,
Exactly, yeah.
so, but,
So
here's the question. We have a hash map, right? Can we convert that to a hash set?
But what would be the key for the hash set?
We just go through and count them all?
Yep. But there's a lot of them.
Yeah. That would be a pain in the neck. We'll think about it though. I'll think about it. I'll come up with an answer. I'll post you an answer. Or you can do, maybe I'll give you a homework assignment to do this. No, you already have homework assignments.
You have to,
But we can just create a new,
There's a solution that I have that I did for the Dracula thing,
comparable.
and that's every single time that you essentially have 10 integers that you declare, and then you say every single time that you go through this, is this greater than you update that, so it's always asking, is this the greatest number, is this less than that, but the greatest number, and you keep updating those counters for the top 10, but it's not efficient, I mean, there's.
No, that's not efficient at all.
But if you
But the
create
question is there a way that we can do this with the already predefined stuff?
you could create a new tree map that does integer string and then just pull everything off of the first container and stick it in the new container.
Yeah, we could. I mean, according to this, it looks like you can do it by, if you make it sorted set string keys equals new tree set based on that. Yeah, but the problem is that just gives you the key set. That doesn't give you, well, wait a minute. We might be able to do that if we were something similar to this. Because what would happen if we took this and at the end of this, we now have that nice map that's in place to do that. What if we did something that said, I want a sorted set by, the problem is
You
that.
have to override the,
Variable?
Yeah.
Yeah, and one of the things that's be a problem, if we try to build it the other way around, it's not gonna work because the
Right.
values could be identical. There could already be multiple copies of that value in there.
And that's what I was saying before with number 10, you could have ties for.
Yeah, I'm gonna think about this. I like this one. This one's challenging. I wanna think about this, so.
There should be like a 5-line way to do this in Java, and then when you finally find it, it's like so obvious that we didn't think of it.
Well, I can guarantee you it'll be in a Stack Overflow entry that was closed for being off topic. All right. So, a couple things. Yeah, that one's intriguing. I want to figure out how to do that. All right, so got a couple things for you to do. We got.
Take on midterm.
Yeah, that's funny. Hey, I'm letting you get away without having a final. All right, so.
That's CJ actually, yeah.
Mhm.
So, for this programming assignment, what we're gonna do is, you need to do these two guys. Using generic collections, write a program that determines and prints the number of duplicate words in a sentence. Hey, we've already done a lot of this stuff. You can probably figure this out from there. Treat upper and lowercase words the same, ignore punctuation. Number 2, use linked list. Write a program that inserts 25 random integers from 0 to 100 into a linked list object in order. Once the numbers are added, print the list and the sum and floating point average of the list. Now, this has to insert them in order. So you got to figure out how to insert them in order. You can't insert them all in random and then sort it. That's not fair.
So by in order, you mean in the order of the values, or
Yeah.
not?
Yeah,
Okay,
it's
so
an
not
ascending
the-
order.
Not the order in which they came out of random number generator.
Right.
Okay.
Sorted data. So this is due the night of the midterm. This shouldn't take you long. You got 2 weeks too, so.
Just one more question on the sorting. Is it something where it's like shortest word and then alphabetically within that length of word? Is that what we're doing, or alphabetically for all words?
What are you talking about?
There's some sorting thing you mentioned?
Sorting in-
Oh, no, okay, never mind, okay. I thought it was
I don't
words.
quite get the second part.
The second one, you're gonna put 25 random integers from 0 to 100 into a linked list object in sorted order.
Oh, okay, never mind, that's easy.
But what we do before that, before we create the linked list, we're free to use other collection classes if we want, or
So you
write
want
our
us
own
to
sort.
like,
No, you have to insert them into the linked list in order. You can't.
while they're coming in?
Yeah, well, every time random.getNext, insert it into the linked list.
So you have to have somewhere else to sort it in and then put it in.
No, you sort them as you insert them into the linked list.
Oh,
So
okay.
we're writing our own sort algorithm.
Okay.
Is that what you're
Yeah.
talking
But based on a linked list.
about? But we can't use the linked list because when we create it, we're going to have to insert the numbers in order.
Can we use our own numbers?
No, you gotta use the linked list that comes with Java itself.
You
You
can't
have a
do it.
way of
I get you.
opening spaces in between things and inserting things however you want into a array list. I'm just saying they gotta be in order.
But we have to insert them in order.
Yeah,
So each insert has to be the,
insert it into the right place in the collection of numbers that came before you.
well, I'm still confused.
Why?
We got.
What's confusing about that?
It's probably where do you put it before, as you
It's
sort
a
it?
single number, insert it into an array list.
Right. No, but you have to sort it against the other
No.
number.
In a relation.
No, you
Oh, an
sort
array
it
list.
as you insert
Oh,
it
okay.
into
Yeah,
the
yeah,
array
yeah, yeah.
list.
Oh, okay. I got you. Okay. Yeah. Sorry. I think the linked list, the terminology,
Yeah.
you got confused a little bit.
Basically, you've got this linked list out
Yeah,
there,
yeah,
right?
yeah.
And
Okay.
let's say, just for the heck of it, it looks like this. And there's number 5, 6, and 8 here. And you want to insert the number 7. So what happens is you got to find out where the number before it is, which is this one, and then insert it here.
Okay, that makes sense.
Like that. You sort them as you insert them. So you only need one number outside of the array list and an array list, and then a for loop, and then some mechanism to sort them as you do this.
I like that when you were drawing the arrows, you actually did it in the correct order so that there wasn't a null, it like didn't delete the rest of the list.
Well, they're all sorted.
No, when you were drawing the arrows, I
Yeah.
thought it.
Yeah, no. Yeah, because if I would erase this first, the garbage collector would
That's
delete
cool.
it before I
Yeah,
ever get to it.
even when you're drawing, you're still thinking as computer scientist.
No, do it in the right order. All right. So, yeah, I'll also publish a more easy to understand. I copied this out of the book. So, I'll publish something tomorrow too that looks a little more easy to understand. The last thing is midterm.pdf. You want that one, right? No.
Just email it to me.
Oh, yeah.
This one. All right, midterm topics, or why did I get myself into this?
This is on Blackboard, right?
It is.
Okay.
Open book, open notebook, not open internet, 12 questions, you gotta answer 10, 3 programming questions, scratch paper provided. Chapters 1 through 9 and 11 through 16 of the book will be covered. So, basic Java, make sure you understand Java. I mean, you need to understand what Java is and how it works and all that kind of stuff, all the stuff we talked about in the first class or two. How to define classes, make sure you understand very well protection types, private, public, and protected. Accessors and mutators, static versus dynamic data. You're pretty much assured there's going to be a question on that on the exam. Java FX, make sure you understand about stages, text controls, buttons, listeners, graphics, event handlers. You guys should be pretty comfortable with that. I'm not going to ask you any logistics about how to get the damn thing to run. Strings and regular expressions, string builder, tokenization, splitting strings, regular expressions, pattern matching. Yeah, there'll be a couple questions about that stuff. Files and streams. You're probably going to definitely see something on XML serialization, and you're definitely going to see something on object serialization, because we talked about object serialization we did after the fact, and we showed you how to build a linked list and do that kind of stuff. You're pretty much guaranteed that's going to be there.
So, if I know I use Jaxby, I'm all set?
Yep,
Okay.
for the XML portion. The object one, that's a different thing. For generic collections, make sure you understand these things: linked list, array list, priority queue, hash map, blah, blah, blah. All the methods that are on them, like bring the slides from tonight, show you about the reverse and sort and all that kind of stuff. Some IDE tools like getters and setters, make sure you understand how to do that. That should have been over with the other stuff there. Some determining of output, yeah, that's fair game. Some minimal syntax. Figure out stuff from the system object too, and interfaces. That's some general stuff. You need to understand interfaces. And one thing I didn't have in here, which
It should be giving like
generics.
asking to write any coding. Or
Yeah, oh yeah, absolutely. Absolutely, it says right here.
3 questions. skip through.
Yes, you can. So basically, look at the book 1 through 9, 11 through 16, and you'll be fine. It's no book test.
Okay.
I know it's no internet. Can we bring a computer?
No.
Okay.
Well, unless your book is on it, but other
That's the
than
whole thing, Command F, or Control F. You just search things much faster.
No.
Okay.
Nope. The only reason you can bring a computer is if your textbook is electronic, and that's the only way you have to access it. Other than that, no.
No computer?
Pretty much, no computer.
It's okay, guys, we remember this.
Can we just have like a grad student with us? Can we just bring that up?
I'm bringing my friend Paul Deitel with me.
He's my study buddy.
Bring your homework.
All right, this stuff is up on Blackboard. You guys are all set. See you in 2 weeks,
Awesome, thank you.
and we'll have an exam. It'll be fun.
You have a computer? Well, it will let you know.